is equal to 500. 1 plus, what is it, 0.08 to the end? Okay. So when we write out an equation, in order for us to change it to a function equation, all you have to do is change it so that the terminology, that instead of where the y is, in this case a, you put it as a function of whatever n is. So all that means is this. I just go a bracket n equals. And that's all that asks you to do. You didn't have to do anything else. That automatically changes it to a function, which then means that if I actually graph this, or if I did a table of values, that it would pass the vertical line test. So all I have to do is change this into a to the n.
And you're getting the n from the n.
From here. Right? Because, just to answer your question in a sec, Bodie. So what that means is, how do I find out what a is? I put in a value for n, and I solve it, and that tells me what a is. That's what this is. That's how I say it as a function.
Whatever's in the equation just goes beside the other.
Yes. Yeah.
In brackets.
In brackets. That's
And
right.
then when you do it backwards, you just like would take the n out and then deviate it.
Yeah.
Because question 3 is nothing backwards.
Yeah. Yeah, that's right. So then in question 3, you'd have w equals 26p plus 1200.
Okay.
Okay?
4 and 5, I got them, but I don't understand what I'm doing.
Well, okay. Let's do this differently than Sammy. I'm going to write an equation though. Okay. Here's an equation, Sammy. In words, describe how I find out what y is.
You have to times -3 add 7. -3 add 7.
So whatever I put in for x, I times it by -3, and then I add it to 7. Do you agree with me?
Yeah.
So no matter what I put in for x, I'm going to multiply it by -3 and add it to 7, and that's going to give me what y is. In words, that's what it means, right? So then let's just randomly select a few x's, and we'll find out what the y value is in each case. Okay, so let's put a -2 in for x. So to write it properly, it means this, -3, and wherever I have a substitution, and this goes for everything as you go forward, if I make a substitution, put it in brackets. That way you understand that I've changed that value for this value, or I put this value in for that value. Okay? So, like that. Equals 13. -3 times -2 is 6. 6 plus 7 is 13. Okay? Let's put a -1 in there. -1 times -3 is 3. 3 plus 7 is?
Or -3, so before.
No.
Oh,
-1 times -3 is? Okay, Sammy.
Oh, sorry, -3 times
-1
is is 3.
is what? 3. 3 adds 7.
10. Sorry, 10.
Want to borrow Lexi's calculator? Put 0 in here. What's 0 times -3? Jake? You're already late. 0 plus 7? 7. Okay, just look at what's happening here. What's the next value? What is it? 4. And what's the next value after that? 1. Okay, because each case, I'm going down how many? 3. Down 3, right? Okay, so that's it. So now, Sammy, you understand what I did here? Okay, so all I'm going to do now is instead of using y and x, I'm going to put in z of a for y, because that's what y is, and then -3a adds 7. So now the first thing asks you, if I put -2 in for there, so wherever I have, what this tells me, okay, so everybody following along here, what this tells me is this, is that in that place of A, I am going to put a -2 in. That's what that means.
Oh, so you're gonna,
So I put the -2 in for A here.
oh, so it doesn't, you're not times in a -2 by Z.
No,
Oh,
no, I'm substituting, this is the input value.
oh,
I'm putting in, I'm gonna put it in for A, and then I'm gonna solve. And when I do, I get 13.
okay, that makes sense.
Okay?
That makes sense.
So what if I do this? What's the equation gonna look like? What is it? Who said that? Yeah, Alex. That's right. What am I gonna put in instead of A? X. So it becomes that. So whatever's in here, I put it in for my A value. No matter what it is. Could be Y, could be 7, could be 100, could be 1,000,000, could be X. Right? It doesn't matter. All it's saying is I'm going to input that into my equation in that spot for the variable. You understand that now? Is that better?
That'll make it a little easier.
Okay. So let's just follow through on 5 then. Let's just take a quick look at 5. So 5's equation is at n of n. Is that what that says?
Yeah, Tn equals I plus
Okay, so then it is 5 plus n minus 1 subtract 4, right? Or n minus 1 times 4, sorry.
Tn.
It's T of N.
Yeah,
Oh, T of n, I thought it said. Thank you. You're talking about Cooper? Okay, so now what's the first thing to say? Let's put T of 1 in, okay? So what am I doing now? Is that 1? Putting it in where? In?
where the n is.
Where the n is, okay, so I'm gonna put a 1 in here. Yeah, what's 1 subtract 1? 0 times 4?
0.
Which one is it?
0.
0, yeah, you're right. Okay, 0 plus 5 is?
9.
5. Tough, you're on the spot. Want FaceTime again? Okay, so that's all I'm doing. Whatever the value is here, I substitute it into my equation and it outputs what that value is going to be. That's all 3, 4, and 5 do. Makes sense now? Okay, what if? What if what?
I mean, for C.
Yeah.
Is it,
Oh, okay, okay, so, here's an, okay, so now, so far all I have done is I have put in an input value and I've shot out the output value. Okay, so the solution, when I get my y, or my function value, okay, that's the output value. What happens if they give you the output value? Alright, can you solve what the input value was? So in other words, what I'm saying is, for all of these so far, I put a value in for x, Jeffrey, and I got a y value. Now I'm going to put a value in for y. Can you get the x value?
Yeah.
Okay, well, let's find out. So I'm going to put a 41 in here. And my goal is to get an n value. So I need to solve for n right now. Okay? So my objective then is to get n minus 1 times 4 by itself. What's the first thing I'm going to do to solve for n? Subtract 5? Awesome. 36 equals n minus 1 times 4. Great. Next step, divide by 4. 9 equals n minus 1. Last step, add 1. 10. So now, having been given the y value, the output value of 41, I was able to solve for the x value, or in this case, the n value that was in the equation. All right? You will always be given one of the two. You just have to find the other. The y is easy because all you do is put it in the x equation and then solve it. But when you're given the y, you have to actually change the equation so that you can solve for it. All right? So I'm going to show you one more thing here. I'm going to go back to this equation right here. Oh, not that far back, right there. So I had y equals negative 3x plus 7. And just for the heck of it, without a value in there, I'm just going to show you how this works. I want to solve for x. Okay? I want to solve this equation so that it is x equals. So what's the first thing I need to do to solve this equation? Subtract 7. Okay, great. So that gives me y subtract 7 here equals minus 3x. Agreed? Yeah? Great. That's a good starting point. What's the next step then? Divide by what? Negative 3. So I get x is equal to y minus 7 over negative 3. And that's it. So if I'm given a number, I can solve for that x value. If I just said solve for x given the equation, that's how I would do it. Now you're not expected to do this right now. But you are because you just did it right here. Except in this equation, I changed that second variable to a number and then I solved it. So you have the ability to do that. All right? It's not new to you. It's something you have done before. Okay? All right. Other questions today? Anybody have any questions today from anything from 6.1 on, basically? Anything in chapter 6? Again, go ahead, Kelsey.
123 and 1. I just don't understand.
For each relation, state the domain and range. Okay. The cost for you and up to 5 of your friends to attend a concert at $35 per ticket. Okay.
Sorry, for 1.
Oh, 1D? My bad. So we want to draw a number line to represent the set of numbers. Hint on a number line, a solid dot means that the value is part of the set. Oh, sorry. All the factors of 5. Yeah, that number too. Okay.
Oh, yeah, okay.
That's my bad. It doesn't really say whether I can go below 0 or not. So let's assume that I can go below 0. Okay? So all you're going to do right now is you're going to list. So list, the best thing to do right now is list your factors. Okay, what are the factors of 15?
1,
1,
3, 5.
excuse me. And more? 15? What else? I have no restriction on this, so we have to assume that we got to use both sides of that 0. So we got to assume that we're going to use -1, -3, -5, and -15 as well, okay? Now, I don't know if they do it in the book or not. All right, but that's what I have. That's my assumption. Maybe because it doesn't give me a restricted domain, meaning it doesn't tell you that it's only natural numbers or it's only whole numbers or whatever. So then how do I show that on a number line? Okay? Is this a set that's an element of all reals?
No,
No, why not?
because it's not a line, so you can't go in between those numbers, it's just those numbers.
Okay, so it's not continuous, it's not a line, it's discrete because I'm only marking off specific spots, right? So yeah, it is not an element of all reals. What could I say? It's an element of which one?
Whole numbers.
No? It would be if I only used 0 and up, right?
Integers?
Yes. Okay, so you're partly correct, half correct, 100% correct. Integers, right? because those are all integer values, positives and negatives. Whole numbers is 0 and up, right?
Could you put closed dot from 15 to 50?
No,
That would count.
because then you're down, because now you're counting everything in between and those aren't factors of 15.
Oh.
It specifically asks for the factors of 15. So that's the exact values, okay? All right, any other questions? Okay, I'm gonna make one up, and then I'm gonna let you work. What is the domain for this graph?
The main
What?
is
Infinity and
The domain for it?
there's a, what was this before?
Okay, remember. What's the domain? How far left does this graph go? How far right does it go?
Negative. Is that
4. Right? We're talking x only here, correct? So the domain for this,
is 4 and 4.
the other line doesn't count?
that's the axis.
Oh.
Yeah, did I throw you with that, girl? Sorry.
Yeah.
0 and 0.
Oh.
Makes sense. Okay? Alright, what's the range for this graph? How low does it go? Negative infinity. How high does it go?
Positive.
Positive infinity, right? Good. What is the slope of this line?
Oh, can you do the line to, yeah.
Go ahead. What is the slope of this line?
Oh, you can't do that.
Hey, help me out here, Juno.
Undefined.
How come it's undefined, Juno?
I remember reading that at the beginning of the book.
Uh,
It has no slope, it's straight.
Well, at least you read it.
How can it be?
At least you read it. Okay. Sean, go ahead.
You can't have 4 infinities, so you can't do the y and x on twos.
Okay. All right. Oh, yeah. No. Don't think like that. Those are not coordinates. Those are not coordinates. That's the smallest to the largest. Okay. Those aren't coordinates because I do have coordinates. Sean.
4.
Okay. This one here, that coordinate is 4 and 0. This guy right here, that coordinate is 4 and 6. Let's say. Right. So I do have coordinates. Juno sounded so smart there. She has no clue why she's so smart. The answer is undefined. Cam, you want to help me?
Is it because there's no change in x to the y, but a change in y?
You got it half right.
It's divided by 0.
Exactly. So it's not divided by x, right?
So you can't.
There's no change in x. Okay. So what is slope by definition? By definition, what does it mean? What is it? Rise over run. What's my rise? There's an infinite number of rises. It's not infinity, but there is an infinite number. Okay, it can be 1, could be 2, could be 3, could be 1 million. Right?
Yeah.
Because if I start at this coordinate to get to the next one, I went up how many? I went up how many? You're special today. How do I go? Here, here's an easy one. Can you do this? How do I go from here to here? How many did I go up?
2.
Samantha Kringle. Look at the values. 4 and 0 to 4 and 6.
Oh, okay. 6.
Yes, there's 2 dots.
I
You're
guess
right.
Yeah.
0 to 6 is how many up?
7.
6. How many did I go left or right to get there? 0. So what is my slope? It's any number, it doesn't matter what I put there. I could put 1, I could put 2 dots, I could put 6. 1 over 0. It is undefined. So why do we say that that's undefined?
Because the x values are the same.
No, well, yeah, okay, yes, that is correct. But why do I say that it is undefined? What determines whether or not something is undefined?
Can't write something like that.
Yes. Can't divide anything by 0. Try it. Go on your calculator, Lexi. You got it in front of you. We know you want to use it. Prove me. What is 1 divided by 0? Anybody know what it's going to get? Error. Error 2 even. Error. Error. Why? Because this is undefined. Any line vertically will have an undefined slope. And I expect you to put that when it comes down to it. If you have a vertical line, you say the slope is undefined. You can put 1 over 0, but I want you to state that it is undefined. Okay? Everybody understand? So how about a horizontal line? What's the slope for a horizontal line? That coordinate 0 and 2. What is, sorry? What's the slope? It's a 0 slope? Okay, so let's talk about this. Rise, how much? How much did it go up? 0. It's not going up, is it? Is it going
Oh,
down?
wait, no, it's the same.
0, right? And then how much did it go left or right? An infinite number, right? I can go 1 right, I can go 2 right, I can go 1 million right. Correct? So it's 0 over a number. So my slope for that line is 0 over 2. Your answer is 0 over 2, 0 over 1, or just 0. That's fine. It is not undefined. Because what is 0 divided by 2? 0. What is 0 divided by 3? 0 divided by 1 million. 0. Still 0, right? Anything you divide by 0, divide into 0 is 0. Okay? So, I'm just helping you out because you're going to see this and this. And you need to know that those slopes. And my mind, I could use coordinates to show that, right? If this was x2, y2, and now is x1, y1, I go 6 minus 0, right? 4 minus 4, I get 6 over 0. So I could show it using coordinates if I wanted to. But what I'm testing you on is, do you actually understand what slope is? Does it go up or down? The answer is 0, then you have a 0 slope. If it goes up and down but not left or right, then it's an undefined slope. Okay? Alright, that's all I have. Is there anybody else? Last chance? Any other questions? Sam, how can I help you?
Okay.
What page?
132.
132?
Number 5.
Okay. Awesome. I really like this question. This again tests your ability. It tests your ability to understand. All right, I'm going to look at the slope. I'm going to give you this slope right here. I want you to tell me what it means. What does that slope mean? Rises 2, runs 3. So how do I go from one coordinate to get to the next?
You go
Up 2 and right 3. Makes sense?
Oh, yes.
This is positive, right? That's okay. It's a good question, right? So if my coordinate was 4 and negative 3, let's say. Okay, it's 4 and negative 3. My slope says go up 2 and right 3. So let's go up 2 from this. What does up 2 take me from this point?
-1.
What do you got?
-1.
Okay, what's the coordinate then?
B. Um.
I'm asking you what the coordinate is. You're right.
For,
You-
for like the,
if I'm going up 2 from that guy right there, which coordinate does it take me to?
Oh,
What do you got, Jacob?
4.
Yes. 4 and -1, correct? Now if I go right 3 of that coordinate, which coordinate does it take me to?
7, -1. 7, -1.
It takes me to 7 and -1.
I thought you said 3.
it's very,
It's 4 plus
You
4.
said 3.
I thought you said 2 plus 3.
Wait,
I don't know why I listened today.
Thanks, Sam. You've been a good sport. Okay, so what have I just done? All right, now you can graph it, and it's always easier to see on the graph. You never know when it comes to this stuff. You graph it. Graph your coordinate. Count it up 3. Or count it up 2. Count it over 3, and it'll take you to the next coordinate. And if you're using graph paper, which you should be, then it's easy, right? But what I wanted you to do is I wanted you to say to me, okay, if it's going up 2 from here, that means that what value is changing here, my x or my y? If I'm going up 2, which value is changing? My y is changing. And if I go right 3, which value is changing? My x value is changing, right? Okay, so that's what that question's asking you, Sam. In 5. So they'll give you the coordinate, you look at the slope, and you go from that point on the slope. So let's do B just because. Oh, I already did, basically did. We'll do it again. 3 and 5, okay? So I had the same slope in the book for that one. So I'm going up 2 from that coordinate. What does it take me to? 3 and 5 is my starting coordinate, and I want to go up 2. 3 and 7. 3, 7. Okay, now I'm talking coordinates here, so don't fire me out a number. I want a coordinate, so give me an x and a y, okay? So now I'm going to go right 3 from that coordinate. 6 and 7. Very good. And there's your solution, right? Okay, again, maybe I don't understand that. Maybe I can't see that. So what do? I graph it and then count it yourself.
So you can add the top one to the second one?
What does the top one change?
The rise.
The rise. What shows you the rise on a coordinate? The x or the y?
Why?
The y is up and down, correct? That's the y-axis.
Oh, yeah.
Okay? So your slope here. Okay, I'm just going to show you this. I don't want to confuse you, but I'm going to show it to you anyways. Okay? If my starting coordinate was x and y, that tells me where to go to get to the next one. So what is it? 3, right? So I add 3 to my x, and 2 up, I add 2 to my y. And that's how I get from 3 to 5, from 3 and 5 to 6, 7. Okay? How are we doing here? Are we okay? Are we better today than we were yesterday? That's the main thing. Are we better today than we were yesterday?
Yeah.
Yeah? Okay. You got the rest of today. We're going to review. Cooper, what's up?
Well, you just take one more. One more.
One more of those? Sure. What?
Just anyone. Second.
Okay, let's do 0, -4. I'm gonna mix it up on you, buddy. 0, -4, and I'm gonna go. My slope is going to be 1 over -3, Cooper. Okay. All right. How much is my y changing? 1 which direction? 1 up. So how do I show 1 up from 0 and -4? 0, -3. Well done. Well done. So I got that there, right? My run is -3. Which direction is that going? Left. How much?
-3.
-3. So left 3.
Yeah.
So how do I show left 3 of 0? -3. So I just add that on, and there's my new coordinate. Cooper, does that make sense?
Give you like a.
You want me to do actually one out of that book? No. That's why you got it, so you can practice. You check your answer. If you don't get it, then we'll do it again. But I don't wanna do it for you. That's why I'm changing it, okay?
Okay.
Right? Cause there's only 4 there for you to try yourself. Okay? Kelsey, go ahead.
When they have the negative on it.
Okay, you're asking me about the third one from the bottom, or the second from the bottom there?
Yeah.
Okay, this is a good question. And I want you to watch this right now. Okay? So there's my slope. 1 over -3, I went 0, -4, -3, -3, right? Okay? Okay, so my slope is that, okay? Which direction am I going now on my rise? Down 1?
Yeah.
Where does it take me to? So my new coordinate is 0 and -5. And then which way am I going? 3, right? So it is 3, -5. Uh-oh. Those aren't the same. So how is that slope the same? Did I change the slope?
How do you?
What happened?
Doesn't it just mean that it goes to both points, the slope?
Okay. What happened here is this. These are the same slope, right? But they're not going to take me to the same coordinate. Because in one of them, in one of these slopes, this is positive, this is negative.
Yeah.
So it's taking me in one direction. It's going up and left. This one's going to take me down and right. It's still going to be both of these coordinates, along with that coordinate there, they're still on the same line. If I graph this out, they are still on the same line. Does everybody get that? It just is they're not the same point. So now, to answer Kelsey's question, what happens when I have this? Now what do I do? Yes. You have your choice. That's right, Lexi. You have your choice. Either make it for the top one or make it for the bottom one, but do not put it on both.
Just a point. It says in the book, it says to the right. So then you'd want to put the coordinate up or down, right? So that the positive would be.
On the bottom?
Yeah.
Yeah, that's fine. But I'm not marking it wrong. Whichever one works for you. Okay? So if I looked at this and I started here, your choice is this or this. Not going to be wrong. You're still going to end up on the same line, just not with the same coordinate. So if you understand slope, okay, let me show you one other thing while I'm on fire here. Okay? Let me show you something else. So those are the next 2 points. To 0, -4, those are the next 2 points. One above and one down below it, right? How do I get to the next one after that? Well, what if I do this? Now what have I done? Has my slope changed?
No.
Still the same slope, right?
Yeah.
But I'm going to go to the second point,
Yeah. Or you could
not to the next one.
Or you could take the new coordinates and just apply the same slope.
Exactly.
Or like it is the same
Yeah,
slope. But the
Okay,
original-
so what Georg's trying to tell me here, in a roundabout way, is if I took this guy and I use this slope, okay, I'm going to end up with that right there. All right? So that's the beauty of this. You have an infinite number of possibilities. Your slope doesn't change. It's just going to take you to different coordinates. Does everybody understand that?
Yeah.
Okay, is there anybody that doesn't understand that? Be honest. You don't, because I can explain this on blue in the face. Good luck for you.
So if you just want us to find like the fifth, one dot or whatever.
No, I'm not, all I want you to do is find the next one, ever, ever. Okay? That's it. And if I ask you for any more than that, then do a table of values. But all I'm asking is, can you go, use your slope and go from one coordinate to the next? Does that answer your question? You choose. So in that one there, you have 4 over 1, is that what it is? You can either make it -4 over 1 or 4 over -1, and you're still good. Okay? Any other questions today? Alright. Oh, I took all class. Lovely. Okay. Go to work on it.
5 and